All right, we'll kick things off in here. It's 11, so anyone that made it here, we appreciate you taking the time to join us here. We'll be going over a tool that we've developed, which goes by the name of the Smuggle Bus. So, a very brief introduction before we kick things off in here. My name is Piotr, Marszalik. Both Michael and I work for a company called Crow Horwath. Most of our time spent at Crow includes performing penetration assessments, red team engagements, and component of which is, of course, everyone's favorite, physical social engineering. And this is from these engagements that we got the idea to develop this tool.
Right. Like Peter mentioned, my name is Michael Resniak. At Crow, I'm a pen tester. I do a little bit of malware development.
Okay. So point of this talk, we will not tell you how to break in, but give you an idea of some things you might want to consider once you do obtain that physical access in. But what we've learned from performing a lot of these engagements is that obtaining physical access is not difficult at all. If just walking in or tailgating does not work, we've noticed that having props definitely helps, as we see one of our consultants here dressed up as a contractor. So doing things like that definitely helps. The other thing you might consider, the things that we like to do, is bring things like donuts, whatever helps, that will allow us to get in. Michael, so from your recent engagements, do you have any good stories that you want to share?
Yeah, so recently I performed a physical security awareness test at a really small community bank. And one of their branches, essentially what we did was we pretend we're IT, we sent out a pretext email, and we get to the branch, IT manager lets us in, and essentially the networking closet was right in the middle of the room. Like, there's nowhere else to put it. So she sits us down there, and we're next to this individual that was sitting next to us. Unfortunately, yeah, she was right next to like the server closet. So we start chit-chatting with her as we plug in, we start hacking, we start chit-chatting with her. And this was a couple of years ago, but at this point, like, the show Mr. Robot just came out. And apparently she just must have been binge watching. She's like, oh, have you guys heard of the show Mr. Robot? It's so cool. You guys in our IT, you're gonna love it. And we're like, no, like, what is it about? So she goes, oh, it's about this like group of people, and sorry if there's any spoilers for those who haven't seen it. It's about a group of people that hack. They're trying to break into a corporation, they're hacking, they're doing social engineering. She goes, you really never know who the hacker is. And I just pause. Like, I don't know what to do at this point. Like, did she catch us? And my coworker he goes, yeah, I mean, for all we know, like, you could be the hacker. Like, so that's probably my favorite story.
Yeah, that's a good one. For me, recently, as far as getting that physical access, has to be RFID cloning. It has made it so much easier. So historically, we used to use the Proxmark, which is a little device with a little antenna. We used to just put in our hand and run the cable through our sleeve and hide in our pockets. In order to capture the signal from someone, their RFID badge, we had to get pretty close. A lot of times we actually had to touch that individual's badge in order to clone it. So again, to avoid any potential HR incidents with our clients, one of our guys actually did some dev on one of these long-range proximity readers. So with that, we can get up to a foot. So we just put that in our messenger bag, walk around for a few minutes, then we go back, and now we got a bunch of cards. And the guy here in this picture, too, for obvious reasons, he chose to become anonymous. So for any clients, future assessments. Okay. So now you're in. Now what? When I obtain that physical access, the first thing I'm thinking about is I need to obtain access to the internal organization remotely. So typically what that means is deploying a device, something like a palm plug style device that will call home and give us that remote internal network access. With those, there's some things you might also want to consider. A lot of clients might disable unused network ports, so again, that might be an issue for you. We can definitely do things like transparent bridge to do the 802.1x NAC bypass, but with that you will require to have a workstation in a room or a different system in a room that you can put in your deployable. You may also consider putting your deployable and do the 802.1x bridge on a VoIP phone, but at that time there's PoE devices that might not work for you. You might have to do some PoE injection. The other common thing to do here that we also do is look for unlocked workstations, keyboard emulators, in particular the duckies have been really popular, so we definitely use those as well. The last one will be, again, the focus of this presentation here is taking advantage of unencrypted system hard drives. So again, historically, what we would do is we would use bootable Callies and copy the local administrator hashes, because as a lot of pen testers will know, especially not as mature organizations and newer clients, they will reuse that local administrator throughout the environment. So for us as attackers, if we have that local admin account, we can start reusing it and get access to additional systems within the network. If all else fails, you can be like our friend John here and just walk out with a desktop from client organization. That kind of reminds me too of one instance where before we developed this tool, we had to plant a backdoor onto a system on our client network. So the issue that we ran into is we had a very small window of opportunity to do that. So pretty much what we had to do is do social in the morning to break in, steal the desktop, implement the malware, and then come back in the afternoon, do social all over, and then put the desktop back in. So steal it and then return it. So that wasn't too fun, but yeah.
All right, so like our traditional approach was to, our goal is to prove impact to the client. Like we were able to social our way in, how are we going to prove that we actually did something? And our traditional approach was to use a live USB Callie distribution, and that we found that to be incredibly slow. We needed a quicker way to get in, get out. The more time you spend in a location, the higher chance you're going to get caught. People just start asking questions like who you are, and at that point, it's safer just to get out as fast as possible. With the live distribution, there's not a good way to set up encryption or essentially, it's just really darn slow. So we came up with SmuggleBus version 1, and what we did was we started looking at Linux distributions that are incredibly tiny. So we want speed, we want to go as fast as possible. So we came across TinyCore. What TinyCore is, it's incredibly modular. You can load in any packages that you want to load in. So if you, for example, if we don't load in any networking, we don't want to trip any network access controls, we don't want to kill that port. So on there, we built a hash grab script, which will find and mount any OS partition and grab those SAM system security files, encrypt them, and then dump them onto the flash drive. And I'll get into that in a second. And then once that's all done, the system's rebooted, powered off, so you're out in less than 59 seconds. To dive a little deep into the encryption part, essentially what we use is an RSA public-private key pair. And the public key is stored on the SmuggleBus home directory. Essentially how it works is when it boots up, it will generate a random symmetric key. The reason why we use a symmetric key is it's a lot quicker to encrypt that data, those SAM system security files that contain the hashes. And then from there, we'll actually encrypt the key with that symmetric, or that asymmetric key, that public-private key pair that we generated earlier, to encrypt the key itself, and then it's all dumped onto the flash drive. So we got the SAM encrypted, the system security, and our symmetric key. To decrypt, it's the same situation, but in reverse. You would just decrypt the symmetric key with your private key, and then you could decrypt the rest of the SAM system security has. Cool. Now we got a little demo to just show you how that works.
Yeah, we decided to do a live demo. We like the risk, so hopefully everything will go well.
Yeah, we'll see how the demo gods favor us today, but... Oh wait, I still need that. All right, cool, you can see it. So essentially, I'm not going to go through how to put TinyCore onto a USB flash drive. It's kind of self-explanatory. There's a lot of documentation out. So I have one pre-built. Essentially, once you've created it, you get your standard Linux distribution. You have your home folder. So on our GitHub, we have essentially all the scripts, the tools for the encryption. We also included the home folder, so we made it really easy to actually set up and implement. So on our GitHub, you'll find the hash grab script that we wrote, reged, I'll get into that a little bit, and as well as the startup script and a profile. The profile itself, we go through it, all it contains is just the standard profile and then just run the startup script. And now the startup script, it's just run, hash grab, and then power off the machine. So if we take that home folder, copy it on there. There is a little, you do have to change permissions since, well, I'm running on Kali, so fix the permissions. All right, awesome. Now, I mean, that's it. We're all like ready to rock and roll. In order to implement that encryption piece, though, because if you don't have any like public key in there, it'll just automatically dump everything unencrypted. That's not what we want to do, especially since we're taking client data off the internal network. If something were to happen to that flash drive, you definitely want to keep that encrypted. So in order to generate those keys that we talked about, that asymmetric key, super simple. We just use OpenSSL. So I'll show that to you. Boom, done, got a key. Now we take that public key, drop it onto our flash drive. Awesome. Oh. Yeah.
The suspense.
Suspense, all right.
Grab your disc.
Yeah, if you want to grab that laptop. We'll unplug this first. Grab that. Sorry, can you unplug it?
So we generate the public private key pair, and that gets generated at random.
Oh, I can show it. I can show it to you after. I just showed it, but I can show it to you after the presentation one more time.
Yeah. Yeah. So we do both. So the symmetric key gets used. So we generate that at random, and then save that and encrypt that symmetric key with the asymmetric to the public and private key pair, and that way we can encrypt the sensitive security with that symmetric key. So when we're about to decrypt it, then we have to first decrypt that symmetric key with the public and private key pair, and then we'll have our symmetric key.
Yeah, so the symmetric key is essentially created upon, it's just created upon each time you run it. So it's different every single time. Hopefully, let's see here. So I have the VGA plugged in. Hopefully this will show up while it's running. It might be a little too fast. No, that's not good. All right, so unfortunately it looks like the VGA it's not switching over to the second monitor. We do have a video that we can show you of it running. Question, yes? Let me try that.
The beauty of live demos.
Yeah, we'll show the video for now, but maybe at the end, if we still have time, we'll do that. Cool, sound good.
Pretty much the whole, this video we're going to show you is just running the whole smuggle bus. That itself, pretty much all it does is, we'll go through, load up, we're booting from the USB drive. It does this thing, loads up the tiny core, the script will show running, and then it will show you running a full instance of security, and then the system shuts down. So it's a pretty quick process, but yeah, we can show exactly what that looks like. Yep, it's fully on. Does not require any interaction from the end user. Correct. Yep. Turn the monitor off. Plug it in. Turn on the computer. Once you're booting, typically, as soon as it shuts down, walk away.
Yeah, you can also, in that startup script, you can also set it to reboot or power off. I mean, it's your decision at that point. Let's see.
So I want to show the decryption. So let's say we got the hashes now. They're safe on your home drive.
That's true, yeah. So we'll go through the video on how it runs. So hopefully this will work at the end. We can get the demo working. But essentially, like here it is running, right? We'd select to boot from the USB flash drive. It'll grab everything, and then we're done. Like, that's it. You're in, you're out, and you can just, at that point, leave the client location. Oop. Oh, man, these slides. Oh, yeah. So for the decryption portion, it's like I mentioned, it's the same thing in reverse. The script that we have, it'll just take the private key that you generated earlier, the encrypted 3 files, and then it will unencrypt everything. We also have it linked to secrets dump, so if you want to dump all those hashes right away, you can do that. Cool. So you can see here it grabbed those 4 files. So we have the key encrypted, we have the SAM encrypted, and we'll just run that against the decryption script. Cool. Just drag this over here. You can see here we just specify the input directory, so that would be I. Yep. And then cool. So we have the output there. Then if we add the -X, we get all the secrets from the machine. We get any local users and any saved credentials from SAM system security.
All right. So in the first version, all we were just pulling is those local hashes. But since we already have physical access to the machine, we can modify the registry. The next logical thing for us to do is start thinking, okay, why not also inject some sort of payload onto our compromised system? At that point, if we could do that, we don't need to worry about any network access controls. And then we can have that system phone home to our servers, and we can get that system level shell without having to deploy any rogue hardware onto our target system. So version 2 of the Smugglerbot is going to look at what kind of techniques we could use in order to get a system shell that executes on boot without any user interaction. So we did have a few requirements trying to think about what's the best approach for this. The first one is we want to have as little impact as possible onto our target system. The main one is cleanup is very important to us. We don't want to put our clients' systems at risk. We want to break anything. And at the same time, we don't want to leave any IOCs onto our target systems. Again, as I mentioned too, the big one is running in system context, because oftentimes we target systems like kiosks, we target systems like conference room PCs that are not used that often, and no one rarely ever logs into those, meaning if we just try to run in user context, then we'll just wait forever and then our payload will never execute. So with our X, the three class of delivery mechanisms we looked at is the traditional registry start keys, we looked at scheduled tasks, and also we looked at the services. Okay. So for registry start keys, this is a pretty well-known technique here. So looking at the order of boots, how the registry works, the main two that we would really want to look at and spend time investigating would be the first two, run services once and run services, because those two execute prior to login. With our testing that we've done and looking at the Microsoft's documentation, it looks like this is something that was taken out of Windows 7. So it might have worked on Windows XP, but not on Windows 7, so it's no good for us. So we moved on to different techniques.
Cool. So the main technique that we're going to focus on is scheduled tasks. Essentially, when you create a new scheduled task, Windows will drop 3 different registry keys into the registry, and it drops a job file into System32 tasks. And what we found is that if you take those 4 files, so if you take those 3 registry keys and that job file and just implant them onto a different machine, Windows doesn't care where it came from or like who the author is. It will still pick it up and it'll still run it as system. And that essentially is our backdoor. That's our way in. So if we can get these 3 registry keys into a target machine and the job file, then that target machine will automatically just run our code for us. So in order to prepare that scheduled task, it's really super simple. You know, we need an attacker development machine. You would create a scheduled task, have it run in the context of system, have it triggered at startup, and then what we use as an action is just a PowerShell one-liner, usually generated from Empire, or you can do Metasploit, your choice, whatever tool you want. And then the second task, like Peter mentioned, we don't want to leave any glaring indicators of compromise onto any of our clients' networks. So we have a second task that will automatically clean the payload up. For each payload, and that will just essentially just delete the first task and then delete itself. What we usually do is just set a delay for 3 minutes. That way, once the computer's fully booted up, establishes network connectivity, that's when our payload executes. And
so now that we have a proof of concept, which we'll do a demo of in a little bit here, we also investigated Windows 10. Could we use the same technique with, by taking that scheduled tasks, exporting those files, and implementing onto a Windows 10 machine? So we did notice that there were a few enhancements that Microsoft has introduced, which pretty much broke this attack. And there's 2 things that were kind of road bumps into figuring this out. So first one is, by default, Windows 10 does have that hibernation file. So we also saw that if the file exists, we as attackers, from an offline state, we do not have full write permission. So in order for us to start interacting, implementing any binaries onto disks, we would have to delete that hibernation file. The other one, looking at scheduled tasks, it looks like there was some additional hashing that was introduced. So we spent some time investigating it though, but through our testing, we didn't have any luck trying to just simply import and export, because due to those hashing updates, it would not run our code. So for Windows 10, what we decided to do is go a different route, try to use the service backdoor. So for us, the lucky winner was the print spooler binary. So what we do here is, when we do have that physical access, we will swap the print spooler. First, we'll back it up and swap over our own hacked version of print spool SV. So then what happens when the system reboots, our code will execute. And all that exe will do, it does a simple system call, which is the PowerShell download cradle, meaning all the logic behind what will happen will be stored on the server side. So once the exe executes, the download cradle will download some code, similar to what happened in Windows 7, the task scheduled payloads. 2 things, or 2 scheduled tasks will get created. One of them will be the actual payload, and the second one will be the cleanup. The other thing that we found, which was kind of interesting, is for the cleanup, even though we are system, we were unable to make modifications or restore the original permissions to principal SV. That is because what we found is that the owner of all the Microsoft core binaries and System32 folders is not system, it is a trusted installer. So to get around that, all we pretty much had to do is change the owner from trusted installer to system, update the ACLs, correct them, make sure they resemble how they're supposed to look like, and then revert the owner back to trusted installer, and we're good to go, just like how we were before we touched the system. Okay, cool. So right now, Michael will go through how to create those scheduled tasks and how to create that service payload.
All right, so this is going to be towards we'll first start off with the scheduled task, and then we'll dive a little bit deep into the registry. But if you create a new scheduled task, right, so we name it live demo. So we set the permissions to have it execute a system. We can set a delay so it runs at startup, and this is exactly what we want. And then for the action, we'd put your payload in the action, so that would be either your PowerShell one-liner generated from like Empire, Metasploit, whatever your preference is. Do calc for now. So if we look into the registry itself, you can see that it creates that scheduled task, it creates that new registry key for that scheduled task. And you can see here, I named it live demo. Can you guys see that okay? Might be a little too small. And you can see there that there's an ID field. So that ID actually links to 2 different registry keys that we need to export as well. So under the tasks section, you'll see, the second registry keys. So here's the second one that we need to export. It's called same thing, live demo. And then for it to actually run at startup, we need to grab the same registry key from boot. So you can see that we have 6 FCA here as well. So once those are exported, you can pop them onto the the home directory inside SmuggleBus, and it'll run. I did create a quick script to automate all this entire process because it is a very manual process. So for the script, it'll essentially export those registry keys and that one job file that was created from the scheduled tasks. And that job file is located under System32 and tasks. So you can see here that it's just literally the XML version of the scheduled task. So we run it, we get essentially input the name of the scheduled task that you'd like. By default, it's just Windows Update for I guess stealthiness, and then we use Microsoft for the author. And then for the payload, it's just a PowerShell one-liner. Grab that, and then it drops everything into a shell files folder. So now we can take these files and place them onto our hash grabber, or sorry, not hash grabber, SmuggleBus. That was the old name, and then it kind of got like switched around. Cool. So I have a couple of them generated, so I can show you. I have a couple pre-made ones here for the demo. We drop into here. All we do is just drop them into the Windows 7 directory, since that's going to be our Windows 7 payload. For Windows 10, it's a little different, since it's going to be using the print spooler backdoor. So like Peter mentioned, it's just a system call out to our web cradle, our web handler. You can also drop your payload into here as well if you'd like.
So while you're setting up too, so when the code runs itself, I know like a lot of you might be asking, so we're working with Windows 7 and Windows 10 payloads. Typically for our assessment, what we will do is we'll have both. So in that shell of files folder, we have folder for Windows 7 and Windows 10. And when the code runs, it will detect the operating system version. So if it's, again, if it's Windows 10, it will implement that binary. And if it's Windows 7, it's going to just jam those scheduled task files in there.
Cool. So the web portion of the script, all it does, you can see here, plant your payload in. When the computer boots, it'll sleep. The beginning script will sleep for 80 seconds till it executes your payload. Now this second part here is a little hard to read, so I exploited it out a little bit. This is the cleanup part. And this is where we don't want to introduce any other risks to the client. It is print spooler, but we still want to leave the original machine intact how it was. So what we do here is that we create that second scheduled task, the cleanup task. We grab the ACLs from the current hacked version and we change it back to, we essentially open up the permissions so we're able to change it. And then we copy the backed up version. So this is the original. We copy the original print spooler service back onto its original location. We set the owner back to trusted installer. And then we apply the proper ACLs and we just remove the backup, and we have the scheduled task delete itself and then start the print spooler service back up again. Then I'll go through a demo at the end just because we can maybe figure out the screen issue here.
Cool. So the latest features that we've added to, so this is more of an optional feature that we'll edit later. So the way the script is designed, by default, we have it so always grabs the hashes. If you want to implement the backdoor, yep, if you generate those files for Windows 7 and 10, yep, you can run those as well. And also if you like to do the classic sticky key sag, which a lot of you might be familiar with, here what we do is we swap the sticky keys binary with the command prompt. And since this is an accessibility feature by Microsoft, we can execute that binary from outside the login screen. So that way, if we do want to get that physical access in right there and then from the console, this smuggle bus can just swap those binaries for us on the fly. So by default, we keep that commented, but again, if someone wants to use that, that's a feature. And the big one too, the latest feature that we've been investigating, again, it's still experimental at this phase, and keep in mind, it might put you over that 59 seconds, because if the client does have a large amount of RAM on their system, that hibernation file will be bigger. So Windows 7, it is not always enabled. Some manufacturers choose to enable hibernation, but it is always enabled on Windows 10. So through our testing, what you can do as an attacker, that hibernation file will contain all of your processes, all the memory, which of course will include LSS, and LSS will contain your domain credentials. So what we can do is we can take that hibernation file, convert it into a Windows dump format, and what that allows us to do then is attach to a debugger. At that point we can find the LSS process, load Mimikatz, and now we just got domain credentials from that hibernation file. And so investigating same attack for Windows 10, looks like the hibernation file has changed in Windows 10. Through reading the documentation, additional encoding was introduced, meaning a lot of the tools that exist that allow you to convert from hibernation to Windows dump format don't work anymore. So that's definitely something that we're experimenting in and looking into updating some of those tools. But if you see a Windows 7 box, you're working with that, that's definitely a feature that we would like to use on our engagements. So of course, the last one, we do have to get into recommendations here. So of course, encrypt all systems is the first one. I know for us, most of our systems within our organizations are laptops, and they're all full disk encrypted. So with BitLocker, with some of those enhancements, it is not as difficult as it used to be to introduce full disk encryption. So that'll be the first one. Also looking into advanced threat protection. So application whitelisting, device gone partial, V5, all those three things could have blocked our payload once it was dropped onto a disk. While let's say the full disk wasn't, hardened, wasn't in there, those three could have blocked our binary from executing, giving us that remote shell. Yep.
All right. So feature development, what we want to do next. Yeah, some of them definitely implementing the hibernation feature. So if we can grab that, it would give us a lot more credentials. There's a couple of updates I do want to make to the scripts. For example, that task scheduling script, it does need to be more robust. Right now it just has a template, and it gives you a schedule, like the registry keys and the job file for that scheduled task. I kind of want to give the user more input, more options. The actual hash grab script needs to be cleaned up a little bit, and I realize that, but that's all in the future. Like Peter mentioned, looking into that hibernation file. We also want to start looking into the Windows credential vault, see if we can pull any more credentials from there, for example, from like Internet Explorer, Chrome, Firefox, like all of those credentials would be useful for an engagement.
Okay, cool. So that's all we have for you guys. So we did list our GitHub. We definitely do want to get feedback from community as far as different ways to execute that backdoor, different delivery mechanisms. That's all the things that we want to have in the future version. So if you guys are interested, like the concept, definitely reach out to us and we can chat. Okay, thank you.
Try the demo one more time.
Live demo.
I know, like, want to go live.
Yeah, thanks.
Usually if you press one of the buttons down here.
So it's actually like
you don't
this
see it on this.
old garbage. So it's actually this
It would
laptop.
be this one.